Tarski's semantics tries to directly code the informal meaning of first-order languages. A sigma structure interprets a signature. It is composed by a collection of non-empty sets indexed by sorts, a collection of functions indexed by function symbols, a collection of relations indexed by relation symbols. The domains and codomains of functions and relations are those of the types of the corresponding symbol. The interpretation of the symbols in the signature can be made explicit as shown in the slide. Fixed a signature and its interpretation in a sigma structure, we assume to have an evaluation of variables as elements in the interpretation of their types. Then, the interpretation of a term is inductively defined as one would expect. The interpretation of formulae is defined by induction. Atomic formulae are interpreted as true exactly when the interpretations of their arguments belong to the relation. Propositional formulae are interpreted as in the truth table semantics. Quantified formulae are interpreted considering variant evaluation, as in the slide. The idea is to consider an evaluation of variables as a family of functions indexed by sorts. We construct a new evaluation by exchanging the function on the sort of the quantified variable with a new one, which is identical except for the value on the quantified variable. Then, universal quantification holds when the body holds for every variant evaluation, and existential quantification holds when the body holds for some variant evaluation. We force the interpretation of a quality to be the identity, or, if you prefer, the diagonal relation. It is important to remark that equality has to be defined on terms of the same sort. So in a multi-sorted signature, we may need many equalities, one for each sort.